Hello everybody. Today we're going to talk about functions and function notation. Functions are an important idea in mathematics, especially in calculus, and it gives us a very convenient way to talk about relationships between two quantities. So the definition of a function says that a function is a rule that takes certain values as inputs. Let me get this right, as inputs and assigns to each input exactly one output. And we can represent functions in different ways. Our first example is using an algebraic equation or formula. So here we see that we have two variables. We have x and we have y, and x is our input variable and y is our output variable. And so the idea is that if you give me a value for x, I will tell you the associated related value of y. We can make a table of values to get an idea what this relationship might be. And so over here we have a table and we already picked a few values that we are interested in. We are interested in when x is equal to 0, what is y? So we can figure this out. So if when x is equal to 0, y is said to be 2 divided by 1 plus whatever that value of x is. So that tells us that y is equal to 2 divided by 1, which is 2. So we can put that in here in our table. And similarly, we can do this for every value of x we are interested in. So x equals 1 would be another one. The associated y value in this case is 2 divided by 1 plus 1. That is 2 divided by 2, which simplifies to be 1. So we have 1 right here. We also want to know what happens when x is equal to 2. So we say y is equal to 2 divided by 1 plus 2, and that is 2/3. I could say 2/3 here, or I could say 0.67 as a decimal. Doesn't really matter, so let's say 2/3. And one more, x is equal to 3. We get y is equal to 2 divided by 1 plus 3. That is 2/4. I could say 2/4. I could simplify it as 1/2. So I'm going to enter 1/2 right here. So that's our first example. Another way that you see functions often is using with function notation, something like y is equal to f of x, and we'll talk about that in a little bit more depth a little bit later. Here f is the name of our function. And x is our input and y is our output. Okay, let's look at a second example of a function. Here we don't have a formula. We still have two variables. We have t and we have w. And t is the time in years after the year 2000. That's how we are defining what t stands for. And W is the number of San Francisco 49er victories in that year. So T equal to 0 stands for 2000. T equals 1 stands for the year 2001, since it's 1 year after the year 2000. And T equals 6. That would be the year 2006. And so here we just have different years. T right here gives different years. And W right here is the number of wins in that year. So we could again write W using this function notation as f of something, f of t. And then we could look at specific entries. So we could ask ourselves, for example, what is f of 6? Well, according to our table, when t is equal to 6, we can find our table, and we see that the associated number in the table for w is 7. And so we have the statement f of 6 is equal to 7. And what does that mean? It means that in 2006, the 49ers had 7 victories. I believe that is correct. And we could make similar statements for any of the other entries. And now that we are in the year 2020, we could even go up to 2019. And I don't remember how many games the 49ers won then last year, but I think it wasn't too bad. One more little thing about functions. We can also represent them with graphs. And so here we have 3 examples of graphs, and the question is, which of these graphs represent y as a function of x? Now, the definition said for each input there's exactly one output. So for each input there is exactly one output. And with that in mind, let's look through and see if that is the case. In the graph, we see the input on the horizontal axis and the output on the vertical axis. So for our first function right here, we can see that if this is 1, 2, 3, if this is 3, we could, for example, go up here and look, what is f of 3? And we could estimate that. It looks like f of 3 in this case is about 2. And we could make a statement like that for every other input value as well. So it looks like every input has exactly one output. So the conclusion is yes, our first graph is the graph of a function. What about the second one? Here we see that we are running in a little bit of trouble. For some input values, we have an output, one output value, but for others, we have more. So for example, for input value 0, when x is equal to 0, what is f of 0? Looking at our graph, I can find 2 points that are right here. So I find the point 0, -2, and I find the point 0, +2. Both are points on my graph, and that's a problem. If I can't give a definite answer what f of 0 is, if it says, well, it could be -2 or could be 2, then that's a sign that this is not the graph of a function. So this is not the graph of a function. Because for some values, I can't give a clear, can make a clear decision. What about graph number 3? That one looks a little funny because it has these open and closed dots, but an open dot or open circle, dot or circle, means that the point is not on the graph, is not part of the graph. And the black dot or the closed dot means that the point is on the graph. And so here we can go through and we can pick an arbitrary value for x, this one for example, and yep, I definitely have one output value, so that works well. The only points that might be a little iffy is what if I look at x equals 2? What is f of 2? If I go up, I hit the graph here, but it's an open dot, so that's not really part of the, I don't hit the graph of the function. It's an empty spot right there, and I keep going, and there we go. This is actually indicate, this point is a point on the graph, and this has coordinates input 2 and output 4. I always give them in that order, so it's input, comma, output. And so I can say that f of 2 is equal to 4. I can make a decision right here. And that is the case everywhere else as well. So f of minus 2 would be 0. And I could go and make a decision, a definite decision for every input value. So yes, this is the graph of a function.